Hi everyone, and welcome to ISV Partner Day Digital. This is the 5th session of the day. David Stewart will be presenting on Azure Data Services and Azure Migration Tools. And without further ado, I shall pass over to him.
Thank you, Alana. So today I'm going to be talking to you about Azure Data Services and Azure Data Tools. Thank you for attending ISV Partner Day Digital so far. I hope you've enjoyed all topics discussed and are primed for more. Justin Davies has just delivered a really great presentation on re-architecting Azure Data Services and re-architecting for Azure, covering apps, data, and intelligence. I'm David Stewart, and today I'm going to be explaining more about Azure Data Services and Migration Tools. We'll start with an introduction to Azure, followed by an explanation of the service types available, such as IaaS, PaaS, and SaaS. Then we'll look into relational databases, specifically SQL in Azure, and what deployment and purchasing models are available. Next, we'll look at assessing, preparing, and migrating database workloads to Azure using DMA, the Data Migration Assistant, and DMS, the Data Migration Service, and how Azure Migrate unifies the migration experience. Finally, we'll go into NoSQL in Azure with Cosmos DB. Before I talk about Azure Data Services in any detail, I'd like to make sure that everyone has a common understanding of Azure in general as a platform. So Azure currently has coverage across 52 regions worldwide, with plans announced for 6 additional regions, and is available across 140 countries/regions. Each Azure geography contains 2 or more regions which are paired. This is designed for high availability disaster recovery and backup to ensure continuity of services delivered from their platform. And each region typically consists of multiple data centers and availability zones where supported. Wherever possible, Azure tries to provide at least 300 miles of separation between data centers in a regional pair. This isn't always possible, sometimes due to impracticalities. This physical isolation means that there is less probability of incidents affecting both paired regions at once, such as natural disasters, power outages, etc. It is best to deploy and configure a business continuity strategy with region pairing in mind. There are a number of services available to leverage, and Microsoft keep adding more and more. Whether you're looking to modify or extend your application to Microsoft's identity platform by integrating with existing functionality which exists in Azure Active Directory B2B, which stands for business to business, and B2C, which stands for business to consumer, for authentication, or whether you're looking to deploy, scale, and manage containerized applications using Kubernetes, Azure has the right solution for you. Talk about some of the features of Azure. Azure is highly available, so Azure SQL Database has an availability SLA of 99.99%, so 4 nines as a baseline, and 99.995% for business critical or premium tiers in regions which support availability zones. Azure Cosmos DB provides read-write SLA of 4 nines, so 99.99% for single region, and 5 nines, so 99.999% for multi-region writes with availability zones. 99.99% availability means that downtime should not exceed 52 minutes a year. 5 nines, however, so an extra 9, means that availability should be at least 5 minutes per year of downtime in maximum. So that's a 90% reduction. Ask yourself, is the extra 9 worth it? Azure's open. It supports open source technologies enabling you to run virtually any application. 1 in 4 Azure virtual machines run on Linux. Azure's trusted, so over 95% of Fortune 500 companies trust their business to run on Microsoft Cloud. More than 90 compliance certifications, the most comprehensive compliance coverage of any cloud service provider is available in Azure. I'm going to be talking to you about the responsibilities. Before I explain why you should move your workloads to PaaS where possible, PaaS being platform as a service. I'll firstly explain the differences between responsibilities and how they shift between different cloud computing hosting models. With IaaS, infrastructure as a service, Microsoft take full responsibility for protecting the physical data center, physical network, physical host, and the operating system of the service. With PaaS, elements such as buildings, servers, networking hardware, network controls, and the hypervisor are managed by Microsoft. The customer still has shared responsibility for securing and managing applications, identities, clients, and data. Some examples of what is taken care of for you in PaaS include patch management, anti-malware, and baseline configuration. If you require WAF features to protect your code/application from exploits, then this is an additional layer on top of your web app, which Microsoft do not provide as part of their cloud service, such as web apps, for example. Consider Azure Front Door, Application Gateway, Traffic Manager, or a combination of these services for features layered on top of your web app. For example, Azure Front Door works with the Anycast protocol, providing HTTP-based routing to your application, providing additional features such as WAF. Application Gateway works at another layer, providing both HTTP and non-HTTP based routing, but it's regional, which means it's bound to a specific region. And then Traffic Manager works at a DNS level. So you do have to wait for DNS TTL in order to propagate for you to be able to route to a new region. With SaaS, Microsoft take full responsibility for protecting all elements of the software applications which they host and manage for the customer. In this instance, the customer only needs to consume the hosted application in order to benefit from it, but they still have to look after their own identities, for example, with multi-factor authentication. Talking about some of the platform as a service features, there's typically a reduction in cost and management in comparison with infrastructure. There's an improvement in scalability and load balancing features, such as application services at Microsoft Web Apps. They include an integrated load balancer, for example. This has simpler architecture and deployment models and offers reduced time to market through the use of the DevOps integrated tools. Talk about a platform as a service solution example for a moment. Working from left to right, so Azure Active Directory, as I mentioned before, can be used as an identity and authentication layer. This allows you to manage identities across different platforms, whether it's with Microsoft Authentication Library, whether that's a social identity such as a Google account or Microsoft account, whether it's a personal identity such as a Google or Microsoft account, or a work identity, for example, and also supporting social identities with B2C, such as Facebook and Twitter. Then looking into the next part, which is Azure CDN and Azure Front Door. As I mentioned earlier, but Azure Front Door works at the Anycast layer. This actually provides, using the Anycast protocol, this actually provides routing based on HTTP traffic. So it doesn't require DNS to update. So this means that you can have a highly available solution without worrying about DNS records. What this means is you can route traffic from region A to region B in the event of a region-wide outage, or in the event that the web app becomes unresponsive, so that you're able to recover quickly in the event of an outage. Azure CDN, it stands for Content Delivery Network. This provides a service which essentially acts as an edge site, which allows you to place your static content from your image, for example, images, closer to your users on your websites. So this means that they not only load quicker, but this also means that the latency and the data transfer is predominantly reduced. So actually, this could result in a decrease in cost rather than an increase in cost. Talking about app service web apps and the remaining components of this particular architecture. So the web apps is sending information to a queue. So this queue could be something like Azure Queue Service or Service Bus example is an alternative, which is then sending information to Function App, which acts as an event-driven serverless execution model, which essentially executes code based on an event. And this is then, in terms of the web app, communicating with two different databases, SQL database and Cosmos DB. SQL, of course, with the relational data, and Cosmos DB with anything NoSQL, such as unstructured and semi-structured data. Now, the Cosmos DB is geo-replicating using the available global scaling capabilities that Cosmos DB have available, and SQL database is using active geo-replication. So both of these technologies can be used to create standby availability in a secondary region. Azure Search is another database type which allows you to search based on indexing text text formats, so you can search in your applications from this text. And Redis cache is another type of database. Essentially, this is for in-memory caching of data to be served up to your applications in a shared cache format. In this model, for example, just to give you some context, the web app will be perhaps sending an upload job, which an API is listening into. That then is processed in a queue, which allows a function app to present perhaps something like the image upload thumbnail to the user. In this section, we'll be talking about SQL. Azure supports other relational databases too. Microsoft offer a high level of support for most popular open source relational databases such as MySQL, PostgreSQL, and MariaDB. These are available as managed services that give you lots of extra goodies, including high availability, backups, security, and compliance. We'll first start by talking about SQL deployment options in Azure. Azure SQL Database Platform as a Service offers 3 managed instance, elastic pools, single databases, and IaaS has SQL in Azure virtual machines. So we'll start with that. SQL virtual machines are easy for lift and shift. They offer full admin control over the SQL instance and the underlying operating system. You can run on Windows or Linux VMs. You can also stop and start the SQL VM as needed. When the VM is stopped in deallocated state, you're no longer billed for the compute and the metered license, i.e. the operating system and SQL license, for example, you'll still pay for disk storage, however. So in the event of shutting down your VMs, if you're shutting down within the operating system, they don't become deallocated because Microsoft at the hypervisor level are still allocating the compute to you. So you need to make sure that if you are not using your virtual machines, you deallocate them. That's stopping them with the Azure Portal API, with the Azure API, which is driven by the portal or PowerShell or the mechanisms. With this, though, there is downtime whilst changing resources such as CPU and storage. So when you think about this, if you needed to resize a machine to accommodate future growth or a quick change in demand, you need to think about that with virtual machines. SQL doesn't scale very well on a horizontal basis, with the exception of things like sharding, for example. But in scaling vertically, however, with SQL in Azure virtual machines, you do have to require to restart the machine. You need to manage your own high availability. So if you need to configure something like always on availability groups, that needs to be done to support a high availability strategy. You also need to manage your own backups and patches. And Microsoft provide up to 99.99% uptime SLA. You can achieve this by creating an additional SQL Server in virtual machine and configuring always on availability groups in a synchronous cluster, for example. So managed instances is going to be the next topic. SQL Managed Instances is a fully managed SQL database engine based on the latest stable version of SQL Server Enterprise Edition. It provides near 100% compatibility with the latest SQL Server on-premises Enterprise Edition database engine. It supports an easy lift and shift migration, but fully managed PaaS and includes all PaaS features and offers up to 99.995% availability. It provides full isolation with a native Azure Virtual Network implementation, along with a private IP address. You can scale dynamically like with SQL Database, which is going to be the next thing I'm going to talk about. However, management operations can take hours rather than seconds. So you've got to think about that when you're scaling Azure SQL Managed Instance. Although there's no downtime incurred, these operations can take time. The reason for this is because it actually provides dedicated compute and storage with options for general purpose and business critical tiers. These use a completely different hardware layer than SQL database. You can also, however, save money using SQL Server software licenses and active software assurance by enabling the Azure Hyper Benefit capability. This also supports features not available in Azure SQL database, such as SQL Agent, MSDTC, DQS, database mail, file stream, file table, and polybase. Now let's talk about some of the core features and benefits of Azure SQL database. So first of all, it's a fully managed service, also based on the latest stable version of SQL Server Enterprise. You will never need to patch and upgrade SQL Server again. Microsoft provides you with an availability SLA of between 99.99% and 99.95%. Sorry, 99.995%. Databases are deployed within a database server, which is a central administrative point for managing multiple single or pooled databases. It includes the ability to configure things like threat detection, firewall rules, auditing rules, failover groups, and manage your logins. You can scale on the fly with dynamic scaling. It's a little bit different to auto scaling, as it instead enables you to scale manually with minimal downtime rather than automatically based on preset criteria. However, you can use something like Azure Automation and runbooks, for example, in order to be connected to something like Logic Apps as an example, so that you can scale automatically using metrics, which is triggered from an alert, for example. So you could use SQL diagnostic settings to send your SQL database metrics to something like a log analytics workspace, which uses a cluster query language, KQL, to retrieve log information. That information can then be executing something like a PowerShell script, for example, which is based on an Azure Automation runbook, or other events. Additionally to this, there are built-in fault tolerance infrastructure capabilities. So geo-replication or failover we'll cover first. With Azure SQL database, not with SQL managed instance, you can create multiple readable secondary databases in the same region or another region using geo-replication. It's a business continuity solution built on the always-on technology of Microsoft SQL Server. It asynchronously replicates committed transactions on the primary database to a secondary database. As it's using asynchronous replication, though, it means that transactions are committed on the primary database before they're replicated as secondary. Combining this technology, however, with auto failover groups enables you to coordinate failover operations, including the ability to configure and perform automatic or manual failover of multiple databases on a server in the event of an outage. Planned failover guarantees no data loss, as it ensures is full synchronization between the primary and the secondary databases before the switch. When using unplanned failover, i.e. forced failover, it won't perform any synchronization with the primary, so this will result in data loss since we're using asynchronous application. You can, however, specify a read-write grace period of between 1 and 24 hours to delay forced failover events. So if you can't afford data loss, make sure that you have specified a good grace period in order to delay those sort of forced failover events if you're using automatic failover. Another thing that includes is backup and point-in-time restore. Azure SQL database includes automatic database backup with up to 35-day retention to any point in time. By default, this is set to 7 days. It leverages SQL Server technology to create full backups every week, differential backups every 12 hours, and transaction log backups every 5 to 10 minutes. The frequency is based on compute size and database activity, though. This also uses read access geo-redundant storage in the back end to support additional fault tolerance and high availability. You can configure and pay for long-term extension which enables you to have up to 10 years of storage for weekly full backups. So if you need to have more retention because of a specific policy, you can configure that in the portal by using long-term retention. Finally, automated optimization and advanced security. So automated optimization, what happens is with this is Azure SQL Database continuously assesses and provides automated performance tuning based on learning your workload patterns. This uses machine learning underneath. So it's based on the R server technology language that Microsoft purchased all those years ago. Think of it as your virtual DBA assistant. Recommendations that are provided include the creation of indexes, which may improve workload performance, or dropping indexes which are redundant or duplicated, and also force parameterizing queries by caching query plans for use to improve performance and reduce resource utilization. You may be thinking, though, that creating indexes will affect the performance of database. And you're right. However, Microsoft do have a built-in policy which only allows the policy to apply if the resource usage is not high. And this takes into account CPU, data I/O, log I/O, as well as available storage. Furthermore, Azure's new Intelligent Insights feature provides a further benefit for detecting events which cause poor performance. Now let's talk about the security options. So first of all, SQL Database enforces SSL at all times for all connections, thereby ensuring that data is encrypted in transit. Additionally, SQL uses TDE, transparent data encryption, to add an additional layer of security by encrypting the entire database using AES. Certificates are managed by Microsoft and rotated, which requires no user input. But you can manage the keys with BYOK, bring your own key, in Azure Key Vault if you prefer to have full control over the keys and the rotation. You can also take advantage of Advanced Data Security, ADS, which is an Azure Security Center feature, which provides features such as vulnerability assessment and also threat detection, covering things like SQL injection, brute force attacks, etc. Now let's get into the deep diving of SQL demo. So I talked a lot about Azure SQL deployment options. Let's showcase this by creating a SQL server and a database, enabling Jira application on a database, and then creating a failover group on a database server. So going to the Azure portal, so portal.azure.com, search in the very top for Azure SQL. This is a shared view, which allows you to manage different types of SQL deployments in one view. Press Add. From here, you can create your database server and your individual database. We'll start with the server first. Create a new resource group. We'll call this one ISV Partner Day RG. Give it a name. We'll call this ISV Partner Day DB Server. For a particular location, I'm going to use East US. Provide an admin login and password. Here you can configure firewall rules. So this enables Azure services and resources to access the server itself. We're going to leave this setting as no. Next, you can enable advanced data security, which I mentioned, which is using the Security Center feature. This is a paid service, but it doesn't cost too much at only £11 a month per server, and with a free trial period of 30 days. Finally, we'll go review and create, and then we'll press create. Now, the SQL server itself in the logical server, it can take a minute or two. So whilst we're waiting, let's take a look at the ARM template that's associated. So if we go back to here, we go to the deployment under template. Now, ARM templates are structured in a certain way. So it has a schema, it has parameters, variables, and resources and outputs. There's no outputs in this particular template. It uses JSON, so JavaScript object notation, in order to define infrastructure as code for Azure to understand what you're trying to achieve with a template deployment. So think about it think about this as a way for you to deploy infrastructure in Azure, which is similar to things like Terraform, for example, if you might be familiar with that. So you could easily recreate and deploy resources, for example, from either existing templates which exist in the marketplace or templates you author yourselves. You can also integrate these templates into your DevOps processes. So if you need to do a deployment, you can actually author your own templates and have the DevOps, for example, deploy this template into Azure as part of your processes. Now, let's create a new SQL database. So back into Azure SQL, if you go to Add, we need to add a single database here. Press Create. What we'll be doing is we'll be configuring it based on a DTU-based purchasing model. So use the same resource group that you've just created. Give it a database name. Select the database server that you've just configured. And then choose your compute and storage. I'm going to go for the basic because I'm cheap. Only costs £3.72 per month, as you saw. Press Next. So here you configure private endpoints, allowing you to provide private connections to the database on the server, and this affects all databases, using an Azure virtual network and a subnet with a private IP address. Azure resources such as virtual machines, etc., would then be allowed to access the database server and its databases securely. So this is where you would configure that. We're not going to do that though for this deployment. In additional settings, you can choose to sample data. So this is based on AdventureWorks, or you can use existing data from a backup, or you can simply create an empty database. Here I'm going to be using the sample database, and I also get the option to choose to enable advanced data security, which I'm not going to be doing. As you can see in this view as well, you also get the ability to specify tags, which are used to enable you to categorize and understand context of bills, for example, based on tags with a tag name and tag value. As example, if you wanted to use your cost centers in here, you can do that. And also if you wanted to label things like production and non-production environments, you can also specify those too. We're not going to do that, and we're just going to create this database. The SQL database deployment can take about a minute. So once done, we'll go through the database blade. Now, while we're waiting for that, I've got one that's already been deployed. So I'm going to go to a database here. I'm just going to talk you through a few things. So in the database blade, there's a few things I want to show you. First of all, under configure, this is where you can configure the dynamic scaling. So I mentioned earlier that you can scale with minimal downtime. So this is an active database right now. It's actually not got any utilization because it's not connected to any applications. But if I wanted to change this to, let's say, an S2, for example, I could just quickly move it up to, that's an S0, an S1, an S2. This is an S2. I can quickly press apply, and it's going to scale it dynamically without really affecting the application. I mean, connections will drop, but the scalability of this is quite interesting. Now, next thing I want to look at is things like connection strings. So here you can retrieve your connection strings. And then the other thing you can do in here is look at things like advanced data security, like I mentioned, ADS. You can enable it there. You can also enable things like dynamic data masking. So you can add a dynamic data mask for your database based on schema, column, and the masking format. You can also review the performance. So here there's the performance activity. So it's going to show you just tuning activity around things like your automated tuning and kind of the queries that are being consumed. Under performance recommendations, this is where your automated recommendations comes in. You can set the automatic setting here, which is the tuning. So here it's inheriting from the Azure defaults from the server, which is set to configure to use the Azure defaults. So force plan is enabled, but creating indexing and dropping indexes are disabled by default. These are off. Going back into here, Finally, I want to show you the query performance insights. So here you can actually look at your top queries by CPU, data I/O, log I/O. You can also click on the query itself. It will show you the T-SQL scripts associated with that query. And you can start looking at things like your information associated with the query. Going back a moment, we can have a look at, furthermore, the long-running queries. So once again, we've got another query here. And this is a long-running query, which it's finding. So it might help provide insights into improving performance with actionable results. Finally, you can actually also send with diagnostic settings, your metrics to Azure services such as Log Analytics, Storage Accounts, and Event Hub. So here, send to Storage Account, you can specify a storage account. Log Analytics, you can specify a storage account archiving today. You can use multiple options as well. And you can also specify Event Hub for event-based messaging. This is potential integration type services that you might be using with Event Hub. But if, for example, you wanted to send metrics such as these metrics here to the Log Analytics workspace, you can configure them here with a diagnostic setting name. And there's another one here called SQL Insights. So SQL Insights is actually a advanced capability which enables you to see even further insights into Azure SQL database. Unfortunately, we're not going to be able to demonstrate that today, but if you do have questions, please ask me. Now, let's enable geo-replication on the database. So this database by now is finished. So what we're going to do is we're going to enable geo-replication by going to the SQL database, specifying the target region. So in this case, West US, clicking on it because that's the geo-paired region. You then select the server that you want to target. In this case, we're going to create a new server. So we're going to call this one ISV partner day DB server 2. I'm going to give it a login name and a password. We press select. We can choose the pricing tier, but only after it's been done, because you can't specify a different size of your database while it's in synchronization with another one. So here I'm going to press OK. It's going to start initializing deployment. It can take a few minutes. So whilst we're doing that, let's have a look at failover groups with another existing server that's been configured. So here's failover groups, and this is how it's done. So you can add a failover group here by providing a name and then specifying settings. This is the secondary server. This is the alternate location. You can then choose a read-write failover policy, which means, which basically is a policy that applies to a failover. So you can choose automatic, which means that Microsoft, if they detect downtime, then they would automatically failover to the new region. Alternatively, you can use manual, remembering that with automatic, you could incur data loss because this is an asynchronous application. Now, this read-write grace period, like I mentioned earlier, can be used to avoid automatic failover in the event of it actually occurring. So this means you're not doing a forced failover until this number of hours has exceeded. So you might want to specify this if you don't want to avoid data loss with an automatic failover policy. Otherwise, you might want to just keep it manual and do it yourself if absolutely necessary. And then looking at databases here, you can add your databases in this view here. Of course, we've already got a failover group in this particular view, so we don't need to do that. And this is how it looks. So what you'll be able to see is you'll be able to see the primary region, which is in this case the East US, and then the secondary region, which is West US. You can edit the configuration here if you need to, which means you can specify the read-write grace period and of course the failover policy. You can remove databases, add databases, but here you can specify forced failover and test failover in this case. So doing a forced failover, like I mentioned, it disconnects all TDS sessions and everything's rerouted automatically to a new server, becoming the primary. It can cause data loss, so please be careful not to switch unless you absolutely need to. That should only be done in the event of a regional outage, for example. Failover is mostly for testing, for example. So if you needed to do testing, this can actually perform those testing. So if I press that now, I'm just going to do a planned failover rather than a forced failover. It's going to now switch the primary and secondary. So as you can see, 2 is currently the primary. It's currently the secondary, sorry, and 1 is the primary. When this finishes, it's going to mean that the primary and secondary will swap over. So if we wait for that, this can take a minute or so. So we're just going to move on to the next part in the slide. Now that you've learned a bit about that, we're going to talk about Azure SQL Database purchasing models. So there are 2, DTU and vCore. So DTU stands for Database Transaction Units. This model provides a bundle compute, so CPU, RAM, and storage, so storage and I/O package, which has been balanced for common workloads. It can be used on basic, standard, and premium tiers. Basic has low CPU and very low storage capacity compared to the other 2, and premium offers much faster I/O and support for in-memory processing. You can purchase extra storage in standard and premium tier. Standard is capped at 1 TB with S3 and above. Premium is capped at 4 TB at its highest tiers. And you can use dedicated DTUs or shared pools, so eDTUs. As you can see in this view, it scales with storage. So you're not able to select the storage tiers as you're scaling up within outside of the confines of what's pre-configured and what's available as additional. Now we'll talk about elastic pools. So elastic pools is a collection of databases which share the same set of resources, which are managed by a logical database server. It's cost effective for managing multiple databases which have varying usage patterns, as demonstrated on this diagram. Now, this enables you to auto-scale up to the eDTUs in the pool per DB, subject to the maximum per DB limit. So thinking about auto-scaling and dynamic scaling, so once again, just to explain the difference, with dynamic scaling, it's a manual scale based on a slider that's available to you through various mechanisms such as scripts and API calls, and of course the Azure Portal user interface. Now, elastic pools enables you to use auto-scaling, which means that essentially you've got a pool of performance which all your databases are sharing, so they're automatically expanding and contracting as they need to consume resources in the pool. However, if all eDTUs are consumed, the performance in the pool will be throttled, with each database receiving an equal amount of compute resource, like the resource governor feature in SQL Server. Premium elastic pools provide access to in-memory processing capabilities as well. So just leading on to that point in the in-memory processing capabilities piece, if you had workload which would be able to benefit from these in-memory processing techniques, it means that you're able to use you'll be able to use in-memory techniques in order to improve the performance, the overall performance of your databases. And therefore, sometimes it means that you can actually not have to scale your database as soon as necessary, which of course can save money. So have a think about the tier your pool sits, in, as well as the single databases, and make sure that you're selecting premium if you feel like you can get benefit from the premium features such as in-memory processing. Now, in this example, I'm just going to talk through the example you have in front of you. So aggregated eDTU utilization across all 5 databases is demonstrated with the white line, indicating that the total utilization never exceeds 100 eDTU. Individually, each of these databases would have required more than 50 DTUs, placing them in what's called the S3 tier, which costs around £137 per month per database. Instead, these databases can be placed inside a single 100 eDTU pool, which instead costs £206 a month, saving almost 70%. So you can save a lot of money by consolidating these databases into pools, but be careful because the price per unit of eDTUs is 1.5 times more expensive than a unit of DTUs. and each database should be individually analyzed because of that reason. So if you have databases with which peak in utilization at different times, they're likely to benefit from an elastic pool. Think about UK and Australia, for example, completely different time zones. If you have a database serving applications to customers in these different time zones, you might find a benefit to placing them in a pool. Now let's talk about the vCore model. So purchasing vCore offers general purpose, hyperscale, and business critical tiers. Roughly every 100 DTUs in a standard tier will typically require at least one vCore in the general purpose tier. It's approximately 125 DTUs in the premium tier. The hardware choices available for new deployments are Gen 5, which has a 1 to 5.1 CPU and memory ratio, and the other choices are the M series, which are memory optimized, and the FSV2, which is in preview and is compute optimized. For existing deployments, Gen 4 was available, however, it's no longer available for new deployments and is being phased out. vCore offers more choice for customization. It means you can independently scale compute and storage needs as displayed on this graph. You're able to scale your compute in differential times across your database. So obviously your storage is going to continuously grow, but your compute demands might change. So this is where the vCore model could work quite well for customers who have that sort of requirement. vCore also offers discounts for existing software assurance / Azure Hybrid Benefit licenses. You can achieve some significant savings by reviewing this, and also things like reserving the compute workload in Azure with Azure reservations could be beneficial as well. We've seen significant savings. For example, we had a customer recently engaging with us who saved over £20,000 a month just by reviewing these sort of things like your reservations and your licenses. Purchasing vCores offer two compute tiers, provisioned and serverless. Serverless is billed by the second with auto-scaling and auto-pausing configuration options. Provisioned enables you to provision resource up front and pay by the hour. Furthermore, the business critical tier also enables access to in-memory technology, like with the previous premium tiers. Now let's talk about migrating workloads to Azure. You can migrate legacy platforms such as SQL Server 2005 through to SQL 2017 to Azure SQL Database, Azure SQL Database Managed Instance, or SQL Server Virtual Machines. It also supports migrating from MySQL and PostgreSQL to Azure Database for MySQL and PostgreSQL, and from MongoDB to Cosmos DB. Let's talk about the Azure Database Migration Service. So this enables you to perform offline and online database migrations, meaning that you can use this for business critical workload at scale, which require minimal downtime. It uses the Data Migration Assistant, DMA, to generate an assessment report and provide recommendations before performing the actual migration. DMS will then perform all the required steps for you, so you don't have to do anything. It's typically used for large-scale migration projects, but also when you have minimal downtime requirements. You'll need to use the premium tier of the database service in order to do this online, but this is free for 183 days for 4 vCores. With offline migration, application downtime begins when the migration starts. With online migration, the downtime is limited to the time required to cut over the new environment once the migration itself completes. But you've got to think about this for a moment, because sometimes downtime is just not a possibility. So you've got to make sure that you pick the right strategy for migration. These are options, so Database Migration Service and Database Migration Assistant are certainly options. However, you might find native technologies such as transactional replication with SSMS could be preferable if you need to minimize your downtime. DMA, so Data Migration Assistant, supports migrating on-premises SQL Server instances, assessments and migrations. And it supports version 2005 through to version 2019. The tool enables you to migrate to a modern data platform, such as SQL 2012 and above, and SQL database and SQL data managed instance. DMA can be used to detect compatibility issues, which may impact database performance and functionality, for example, in your migration target. DMA will also affect partially or unsupported features that are not currently available in the source, in the target, sorry, that's used at the source. For example, SQL agent, CLR, cross-database queries, and sys packages. So talking about sys packages, SQL Managed Instance does support this. However, it uses Azure Data Factory, which is the managed service version of SQL Server Integration Services. Other options, for example, Azure Analysis Services is available as a service, a cloud service to allow you to run tabular models based on compatibility level 1200 and above. It does not, however, support multi-dimensional models. And SSRS, so SQL Server Reporting Server, is available in, for example, Azure SQL virtual machines, however, not available in any of the managed service options. If you want to, though, Power BI is a really good business intelligence solution for you to migrate to. Of course, you can still read databases from the cloud. You just can't use them to kind of host these components. So one of the other things it can provide is alternative approaches available in Azure, like I mentioned just then, and any mitigation steps to help plan the change ahead of the migration project. It's also used to recommend performance and reliability improvements. And finally, it not only works by moving the schema, data, but also uncontained objects, users, server roles, and SQL and Windows logins from your source to your target. Note, though, that Windows authentication isn't supported for Azure SQL Database, and it's recommended to use Azure Active Directory for authentication over SQL. Your assessments can then be uploaded to the Azure Migrate service. Here's an image just to showcase the DMA. As you can see, the unsupported features across database is not listed, and so is the Windows authentication. Now, let's talk about the Azure Migrate service, which was briefly mentioned then. So servers can be assessed and migrated with Azure Migrate, which is a single unified resource for migration activities. This is included for the first 180 days. Furthermore, databases use this service as part of the migration activity. So this means you can perform assessment using DMA and DMS, and these can be brought into the Azure Migrate service. So this will instruct and guide you through that process. I'll showcase this soon. On-premises Hyper-V VMs and VMware VMs are supported. So with VMware, you have to have vCenter. Hyper-V VMs, you just have to make sure you have the Hyper-V account. There's also support in preview for physical servers. The discovery collects metadata, such as machine name, disks, cores, memory, and performance counters, such as disk read-write, CPU and memory utilization. However, you need to make sure that the machine has the means to collect this information. So you need to make sure that this is turned on. Furthermore, you need to make sure that you're running the migration tool for a certain period of time, such as a minimum of 48 hours, in order to gather sufficient information to be used as part of the migration analysis. And finally, this includes the dependency visualization, which discovers interdependent systems that should be migrated in groups. Think about an application and a database workload. It allows you to understand that these systems are interdependent of each other, and you can migrate them together. The database migration guide provides step-by-step guidance for any given source and target. It's a really good resource. It'll provide pre-migration, actual migration, and post-migration phases and information around each of these phases. Let's take a tour of the Azure Migrate service and the resources explained. So I'm going to demonstrate the Azure Migrate service in the Azure portal. So in the Azure portal, search for Azure Migrate. We go to the discovered servers. So under here, This is where you can specify migration projects. So under change, the existing migration projects are specified here. Now, if I go to one I've got here, for example, if I go into the Azure sponsorship with this one, this is one I've already got created. So if I want to create a new one, if I press that and press click here to create new project, it's not obvious, but this is where it is. Click here to create new project. I can then select the resource group I want to create this in. Give it a name. Can't be spaced. Press next. Select the migration tool. So the server migration can be added here. You can also, when you finish this, you can add the database migration tools as well, which I'll show you in a moment. And then finally, you can select the actual migration tool. So that's the assessment tool. This is a migration tool. And then press add tools. This won't take very long, and there we go, that's finished. So from here, you can then go through discovery and adding additional tools. So if I go to databases at the moment, I can press add tools. And this is where you can add the database migration assistant, the migration assistant. And this way you can also add the migration tools and then add as well. As you can see from the previous view here, you've got options to add for other things such as your web apps, which uses the App Service Migration Assistant, Databox, which allows you to send information to Microsoft essentially in a box format. And here, this is where you discover the infrastructure items that's associated with your migration project. So let's go through that. So going to a completed assessment for a second, if I change the project back to the one that we did earlier. So here we can look at the discovered servers. And from here, you can see a number of information associated with the appliance that is being used. So what we're first going to do is create an assessment. So I'm going to show you what this looks like. So here, the assessment allows you to view information associated and edit information associated with what you want to see in the assessment. So for example, you can specify things like target location, the storage type. In this case, I'm using UK South. Storage type, you can choose whether you want to have premium SSDs. So these are really fast disks based on premium SSD, or you can use HDD, for example, or a standard SSD. You can also specify reserved instances, which allows you to achieve a saving of, like I mentioned here, up to 82% over pay-as-you-go rates. You can offer 1 and 3 year options, and these can be paid monthly, or you can, of course, have no reserved instances. You can then specify the sizing criterion. So in this case, you can do a performance-based criteria, which is based on the performance counts that it's collected, or you can do based on as is. So in this case, it would just do the, for example, the CPU and memory and find a right-sized virtual machine based on that information. But you can use performance-based to get the history based on specific percentile. You can also apply a comfort factor. In this case, you can go all the way to 2. So you can apply, let's say, if you have a 10-core virtual machine, which is utilized 15% of the time, for example, that's of course 1.5 cores. In this case, that would, of course, provide a 2-core virtual machine. But if you had a comfort factor 1.3, for example, it would actually provide you a 4-core virtual machine, which is a next core that's available in Azure. You can specify these series as here. So DV2, DV3, DSV2, for example, all these kind of services, these series are available. If you didn't want to include things like the M series, which is very memory optimized, or maybe you want to not include the L, which is storage, and the high performance compute options, you can make sure you don't include those options as the VM sizes. And then finally, you can specify subscription types. This is the offer type that you want to use. The currency, of course, can be specified here too. And then finally, you can specify the uptime. So here, if you wanted to, let's say you had this particular assessment with this particular appliance is maybe using, maybe the virtual machines are only active for let's say 20 odd hours a week, for example, maybe they're only running, let's say, 5 hours a day for 4 days a week or something, or maybe they're active between 7 a.m. and 7 p.m. because it's VDI workload. You can specify 12 hours, for example, here, 12 hours per day, and the number of days per month that you want to keep those up, for example, and then it'll reduce, of course, your total cost. In the event of using the metered rates or the reserved rates, you'll be paying for full base compute rates. And then you can specify Azure Hybrid Benefits. So this is where you're saving money by using an existing Windows license, which you can either purchase or reuse if you have available licenses. And then you can save, which will then create the assessment. Next, I want to do is I want to go through creating a new project. Demonstrating the data migration guide as well. So from here, if I go to the database migration guide, we can look at SQL Managed Instance example. It's going to load a scenario for us. Before I do that, I'm just going to go take you back here and just show you, as you can see, the pre-migration, migration, post-migration steps are all available here, explaining how it kind of works. For example, in the pre-migration phase, you might look at asset discovery, assessing the workloads, providing recommendations for fixing them, and then also looking at schema conversion to work in the target environment. And then migration, so this is the actual migration, data synchronization, and the cutover from the source to target. And then the post-migration steps, so this will be things like optimizing and making sure that your application changes up to date as well. Let's have a look at SQL Managed Instance for a moment. So as I mentioned, 2005 and above, this supports for from these SQL Server versions. And the following data migration options are available. So in this case, transaction replication, like I mentioned before, is one choice if you can't afford that cutover period of downtime. If you have critical workload that you can't use the migration tools for, in this case, these two, transaction replication could be an option. Another option is just importing, which it's going to be relevant, for example, if you wanted to import a backpack file. Couple hundred gig, for example, might be available for you to upload into a storage account and then use that as an import, but it does take quite a long time, and the application and the database does have to be down during that time, so it's not really designed for larger database workload or anything that needs to be online. Prerequisites here, so it's explaining all these prerequisites of what you might need to do as part of the migration project. So it's going to explain things like the detail around the prerequisite information, such as creating the Azure DMS, the data migration service, as well as the assets, for example, associated, and some additional work resources such as the total costs of ownership calculator. Then I'll go into the pre-migration information. So here, to discover, assess, and convert. So it's explaining the steps associated. Another thing you can use in a discovery is using a map toolkit, which is another toolkit for IT infrastructure type assessments. And that, yeah, furthermore, you can look at the assessment using my DMA, Data Migration Assistant. And here's the steps that you'll be able to go through as part of the assessment. It's giving you nice and easy steps. And finally, the actual migration. So this is the schema and data. So in this case, it has mentioned sys, which doesn't support migrating sys packages from SQL. However, you can provision sys in Azure Data Factory, like I mentioned, and you can redeploy those sys packages to the SQL managed instance in that way. And finally, schema and data migration steps. So this is how you do it. You follow these steps. And then there's a detailed guide. And of course, there's sync and cutover if you're using online migrations. And finally, post-migration, which is the tests, optimizing and looking at remediating your existing applications. Let's go and have a look at the migration service. So in here, your database migration service is available. So you can create a new database migration service. From here, you can then create new migration projects based on a project name, a source, and target. So here you'll specify where you want to go from, where you want to go to. In this case, I've selected SQL, and I'm going to go to Azure SQL, for example. And then here you specify whether you want to do it offline, online, create just a migration project only, and then do the activity afterwards, or just do a schema-only migration. And then when you've done that, you can create and run activity. Here, when you've done that, if I show you one I've done already, you can add the activity separately if you just do a project only. And here I want to maybe add offline owner migration. You go through the process of specifying the detail, and like I said, in the background it will just do it for you. You don't need to do any further activities yourself, and it will tell you when you're done and when you can perform the cutover with an online migration. Otherwise, with an offline migration, the downtime will begin immediately. Now that we've done that, let's go through NoSQL in Azure. So relational databases are great for online transaction processing, but with the increased demand for big data, this has led to the need for bigger databases. NoSQL data stores are able to scale much larger than relational database management systems because they satisfy fewer requirements than relational databases. Azure Redis Cache, which was mentioned earlier in my platform as a service diagram, is a managed service for Redis and can speed up data retrieval in apps since data resides in memory. Azure Data Lake Storage, which is another NoSQL data store, it's massively scalable and enables you to hold any kind of data, whether it's unstructured, semi-structured, and structured. And it comes with full Azure Blob Storage features, such as access tiers, which are available for hot, cool, and archive. And also data lifecycle management, which enables you to automatically manage the data lifecycle by placing data in different tiers based on the last access dates, for example. And also HADR support, such as GRS and ZRS, for example. Now, today we're going to be talking about Cosmos DB. So what is Cosmos DB? Azure Cosmos DB provides unlimited scale with guarantees for latency, throughput, availability, and consistency. Microsoft's globally distributed multi-model database. It's single NoSQL data engine, enabling you to select the best API for your requirements for each container within your account. It natively supports multiple data models, including documents, key value, graph, and column family. It also supports database APIs to access and query the data. SQL is the default API. MongoDB, Cassandra, Table, and Gremlin are also available. There are guarantees for single digital millisecond latencies at the 99th percentile anywhere in the world. Azure Cosmos DB SQL API supports querying items using SQL to query against JSON data where the query results are returned in JSON. Azure Cosmos DB has a schema agnostic indexing engine capable of automatically indexing all the data it ingests without requiring any schema or secondary indexes from the developer. In a relational database, you have to create the schema and then define indexes on top of it. In Cosmos DB, you can skip all of that. You don't need to worry about any of that. Throughput, which is the way in which the database itself is kind of measured in terms of performance, for example, in how you're paying for this. It's represented as what's called request units per second. Think about it like DTUs with SQL. Cosmos DB uses RUs, which is a measure for the cost of read-write operations against the container. Azure Cosmos DB also uses partitioning to scale individual containers in a database. In partitioning, the way it works is the items in a container are divided into logical partitions, which are formed based on the value of a partition key that is associated with each item in a container. Now let's talk about consistency levels in Azure Cosmos DB. The consistency levels are strong, bounded staleness, session, consistent prefix, and eventual. In relational databases, strong consistency guarantees are important. SQL databases scale vertically, increasing the capacity of a server or service to scale your database. Scaling out can be done with database sharding, but this can dramatically increase overhead and can be costly and time consuming. With NoSQL, databases scale horizontally and enables access to multiple consistency models which each have consistency and performance trade-offs. NoSQL databases are a much better fit to store data like article content, social media posts, sensor data, and other types of data that won't neatly fit into a table. To give you an example, you can get approximately 2 times more read throughput for the more relaxed consistency levels, such as session, which is default and is in the middle in that view diagram there, consistent prefix, and eventual, so the ones going to the right hand side, compared to stronger consistent levels such as bounded staleness or strong on the far left hand side there. Session consistency, like I mentioned, is the default level, and this applies to all Cosmos DB accounts. The client, for example, in an example where session might be used, the client uses a session token internally with each read/query request to ensure that the consistency level is maintained. Think about an application or connection which creates a session. It provides a good balance of performance and availability. Now, maybe anyone has any questions. I'm just going to ask if anyone has any questions.
I'm just going to jump in there quickly, David. Unfortunately, we're out of time for questions, but if anyone does have something, then please head over to our LinkedIn community page where you can post questions directly now, and David will be more than happy to answer them.
Thank you, Alana.
In the meantime, I will just like to share a few slides in closing. I'll just get my screen up. There we go. So if anyone does have any immediate inquiries or questions, then please email info@greymatter.com or give us a call on 01364 655 100. As I've already mentioned, please join the conversation on LinkedIn. You can search Grey Matter ISV Partner Community. And I would just like to call out some of our services particularly in relation to this session that David has just delivered, our Azure cost analysis, where we can take a look at your current environment and see where you can make cost savings, as well as a remote discovery workshop. So thank you once again, David. That was a fantastic session, and hopefully we'll see you on the next session of the day. Thanks all.